For this exercise, the robot is made to move along a rectangular path. 2 runs will be performed and they will be demonstrated later in this video. This video will be split into, again, 2 parts, where each part corresponds to a specific run. For the following first run, the robot will move in a rectangular trajectory and it will make a 90-degree turn. And this 90-degree turn will be done only using encoder data provided from the motors. By counting the number of encoder ticks needed for every angle, a function can be written to get the number of encoder ticks required for any specified angle. Now a video of the robot's run will be displayed. For the following second run, the robot again will move along a rectangular path, but this time the turning will be done using data received from the IMU. The IMU will provide the robot's angular orientation on the ground, and this will be used to check if the correct angle was found during turning. So when we have an initial angle, the current angle of the robot or the current orientation of the robot will be subtracted from the initial angle to find how much of the turn has been completed. Now a video of the robot's run will be displayed. As you can see, the path in the second run seems more accurate. This is because the IMU is a much more accurate way of finding the angular information as compared to an encoder. So in an encoder, it's more about hoping that the result will come, while in an IMU, we get the correct values that we require. Also, another problem with the encoder is that the encoder cannot work with decimal numbers. There's always an integer number of ticks that are recorded. So for example, if an angle requires something like 7.5 ticks, we will never be able to get that. And therefore, the angle will be wrong. From all this, we see that using an IMU is much better than using an encoder, and the videos show this as proof.